Okay, year 10. So we've been looking at radioactive decay, and you started to look at the concept of half-life. Half-life just tells us that although radioactive decay is completely random and we can't predict when a particular atom is going to decay, we can look at a particular type of radioactive substance and roughly predict how long it will take for half of it to decay. Okay, now what we're going to do here is we're going to model that with dice, and ordinarily you'd be doing this in the lab with 200 real six-sided dice and counting how many sixes you get, but obviously we can't do that at the moment. So what we're going to do is I'm going to use this app I found on the App Store that can roll 200 six-sided dice, and every six that comes up represents an atom that has decayed. So each time we roll the dice, any dice that came up as 6 last time don't get put in for the next roll of the dice. And I'm going to roll these dice 20 times. So you'll see what happens as I roll them. Okay, and it's really important that you realise that this half-life can apply to lots and lots of different things. But here each dice is representing an atom. So any dice that comes up a 1, 2, 3, 4 or 5 hasn't decayed in this particular time period, but the sixes have. So let's roll. Okay, so I'm going to roll the first 200 dice now. So on roll 1 we have 37 sixes, and that means remaining dice is 163. So I'm now going to roll 163 dice because the other 37 are now gone. They can't decay again. And again, I've now got 27, and the remaining is 136. So now I'm going to roll 136. 31 of them are sixes, leaving me 105. Now notice these numbers are completely random. Sometimes they go up, sometimes they go down. Okay, now I'm going to roll 105. And I've only got 17 this time, which leaves me with 88. So I'm going to shut up now, but I'm going to keep rolling these dice, and you can just fill the rest of your table in as you go. Okay, so I'm going to roll the first 200 dice now. So on roll 1 we have 37 sixes. Okay, so if we look at these results now, you can see these numbers down here look really random. Okay, but these numbers down here go down in a fairly steady pattern. And if we look, remember that half-life is the time it takes for half the remaining atoms to decay. Well, half of the atoms have decayed from 200 down to 100 in about 3.5. From 100 down to 50 has taken about another 3.5. From 50 to 25, about another 3.5. From 25 to 12, 4 this time. Okay, and from there down to about 6, about another 3. So the half-life of these dice is about 3.5 throws. Okay, so here is a graph of the results for the dice throwing experiment, and you can see, although there's some randomness in there, as we said, places like here we've got a slightly odd result, okay, and here we've got one that's slightly above. It actually fits the best fit line really well, and this is called exponential decay. And we can work the half-life of the dice throwing out from this experiment, because what we can do is we can take the 200 dice we started at and we can draw a line on at half of that. And then from there we can come down and we find that it's just over 3.5 throws. If we go down then to 50, which is half of the 100, we get to just over 7, which is another 3.5. And in theory we can go down again. So if we go to 25, just over 7 to 11 is about another 3.5. So the half-life for the dice throwing is approximately 3.5 throws. If we do this in the exam, we always do at least 2 half-lives, so 2 sets of lines. Okay, so now an experiment you can perhaps try at home. What I've got in here is 100 coins. In my case they're all 1p's, but for you they could be anything you could get. So if there's a small change jar at home, doesn't matter if they're all different types of coins, they can be 1s, 2s, 5s, 10s. The key thing is they all have 2 sides to them, heads and tails. And so unlike with the dice where there's a probability of 1 in 6 that a 6 turns up, here if we choose heads there's a 1 in 2 probability. And so what I want you to do, if you can do this one, okay, is get a pot and something to throw them into and throw all the coins in. So I've got 100 coins in, and what I want you to do then is take out all the heads and count them. Okay, so I've just done that, and we'd expect probably 50. And actually I've got 49, so that's pretty good. Remember, it's a random process. Now, the next thing to do is to take the remaining ones and throw them again. And keep on doing this, just like we did with the dice. And what I want you to do is to keep doing this until you run out of coins, and then try and work out the half-life for a coin. Okay, it's actually quite obvious if you think about it. So that's just a little experiment for you to do at home.